Okay guys, last test of 2018, linear functions, systems of linear functions. I know this is all not your favorite thing to do, but we just got to get through it. It's important to get through it, and we're going to get through it. So let's work on this practice test. I do need, hold on. To do this test tomorrow, you're going to want a calculator, but you're also going to want a straight edge because we are going to be doing a lot of shading and drawing lines. You might actually also want to get two different color pencils or pens. That might help you a little bit if you're somebody who has a hard time with the shading. So we're going to start with question one, and question one is just asking us to graph these two lines. And because they are systems of equations, that does mean that they're going to ask us to shade. So that's really where this is coming on. So don't forget, you're going to get this fun little sheet that goes with the test for tomorrow that is going to kind of give you some helpful hints on whether you're going to shade above the line or below the line. Also to remember that this is your continuous line. When you have the equal sign under the inequality sign, you have a dashed line when it's just a greater than or equal to. This little remember down here, I'm going to bring that to your attention a little bit more into the practice test because that is going to be needed for our word problems. But for this one, we're just graphing it. And the nice thing about this graphing is that it's already in y equals form, so we can start with the starting point. So I'm going to start with this guy right here. I'm just going to make a little red dot so we know that this is the red line. I'm going to start at -4, 1, 2, 3, 4, because that is actually the starting point, that in the equation, this is your starting point. So starting point, -4, and the signs do matter. Our slope in this case is -1 over 2. So I can actually start down here and go down 1 over 2, down 1 over 2. And that's my line. It's low, but it's down there in those quadrants. Now, don't freak out if your graph isn't perfect, because again, Mrs. Pennington in this question isn't asking you for a solution. She's asking you to graph, so we're going to try to do the best we can. The second one is going to be, I'm going to put this little blue dot here. We have x plus 1. So we know that our starting point for this one is going to be 1. We're going to start here. Also, there is no numbers in front of the x, so we know in that case that our m is going to be 1 over 1. Because if there's nothing in front of our variable x, then we know it's 1. So I'm actually going to go up 1 over 1, up 1 over 1. Get a couple of lines there. And there. Both of these inequalities have the equal sign underneath them. So that means we are going to be drawing a continuous line. But here's where the tricky part of this comes in. It's the shading. I'm going to take my red line. I'm going to look at this sign. Y is going to be greater than the equation. And right here we see greater than. It means we shade above the line. So I'm just going to lightly kind of go like this. Okay? And when you're doing this with your pencil tomorrow, you can just lightly shade above, just like that. For our blue one, we're going to look and see that the equation, y is going to be less than the equation. We're going to look down here and we're going to see that that sign means we're going to go below the line. Below the line is going to be this way. So again, just lightly kind of coloring that in. And the answer to this inequality is going to be any point that's in these two where the shading matches. So in this case where there is both blue and red. This question doesn't ask us for a point in that line, though other questions on the test do, but just so you know, your answer is anywhere that's in that shaded area of both areas. Okay, question 2, straightforward, solve it. So right now we're looking to see where those two lines cross. So we're looking for an x point and a y point. So the first thing I'm going to notice about this one is that I've got a 12y and a 12y, so I know that I can use elimination for this. I always say I want to add down. I want to add everything. So the way I like to do this is I'm going to take that first equation I'm going to multiply it by -1. That's going to change the sign of everything in the equation. And then I can use the second equation the same way. Some people in my second hour class say, Ms. Rooney, I don't want to add down, I just want to subtract everything. That's fine too. You're going to get negative numbers when you do it that way. You just need to watch your sign. Both ways work. So I'm going to do this. -4 minus 8 is going to be 4x. These two are going to cancel out. Equals -72 plus 84. I think it's going to be 12. Hold on. -72 plus 84 is 12. I was right. 12. Divide by 4. Divide by 4 to get x by itself. X is going to equal 3. That's half my answer. I still need my y. I'm going to take the second one. No reason, just am. 8 times 3, because that's my x, plus 12y equals 84. 8 times 3 is 24, plus 12y equals 84. I'm going to subtract that 24. I'm going to bring this 2y down, 12y, sorry. And I'm going to go 84 minus 24, I think it's going to be 60. Divide by 12. Divide by 12. My y is going to be 5. So my answer is actually 3, 5. Now again, you could put that in y equals form and graph it on your calculator. You could try elimination. This was just the most obvious answer for me to do it by elimination instead of a substitution or graphing, because I had those two 12s and I knew I could manipulate them. Okay, let's look at this question. It says the lines of y equals x plus 1 and y equals negative x plus 3 are graphed. What is the solution to the system? Well, if they didn't give us the graph, I'd have to do something where maybe I made the two equations equal to each other and find my x and then my y. But they give me the graph. I know that the solution of a system is where the two lines cross. So my x is 1, my y is 2. So 1, 2. That's my answer. Very wordy question for what that you want, but that's all it is. So look at there. You're done with page 1. Let's move on to page 2.